Good morning, dear children. Today we'll be starting a new lesson, that is sulfuric acid. So last class we learned about nitric acid, how it is prepared and what are some of its properties. Today we'll be learning about sulfuric acid, and as per your reduced syllabus, preparation of sulfuric acid is not there. That means manufacture of sulfuric acid is not there. That means directly we'll go for its behavior. So before going that, let's have some general knowledge about sulfuric acid. So what is the molecular formula of sulfuric acid? It is H2SO4 and its molecular mass is 98. Then this is the structure of sulfuric acid. Sulfur is surrounded by 4 oxygen atoms, and this oxygen atom is linked to this hydrogen atom, and this oxygen atom as well is linked to this hydrogen atom. So this bond, this bond and this bond, any of these four bond, you can see here 4 covalent bonds. Any of these 4 covalent, out of these 4 covalent bonds, 2 of the bonds are coordinate bonds. 2 of the bonds are coordinate bonds, which is formed by sharing two lone pair of electrons by sulfur. That means in this compound, in this molecule, sulfur is donor and oxygen is acceptor or receiver. So either this or this bond is coordinate bond, or this or this, any of these. Out of 4 bonds here, 2 of the bonds are coordinate bonds, that is formed by sharing 2 lone pair of electrons donated by sulfur. So this is the structure of sulfuric acid. Actually this is not in your syllabus. Then also I'm just showing you in order to make you aware about the structure of sulfuric acid. Now let's see about its behavior. So dilution of sulfuric acid. Now before starting its behavior, let's see how to dilute sulfuric acid. Okay, how to dilute sulfuric acid. So water is never poured on acid to dilute it, as a large amount of heat is evolved which changes poured water to steam. The steam so formed causes spotting of acid, which can cause burn injuries. So dilution is done by pouring acid on a given amount of water in a controlled manner by continuous stirring, else acid being heavier will settle down. The evolved heat is dissipated in the water itself, and hence the spotting of the acid is minimized. That means never put water in acid, rather put acid in water slowly and with continuous stirring, so that the heat produced, because mixing of acid and water is exothermic, it produces a large amount of heat. If you put water in acid, then what will happen is whatever you are putting in acid will convert to steam, and this can cause spotting of acid, and it can cause burn. So instead what you have to do is put acid in water, not water in acid. Put acid in water, and that too very slowly with continuous stirring, so that acid being heavier settles down and the heat evolved is dissipated in the water. Okay, now properties of dilute sulfuric acid. Acidic property. Dilute sulfuric acid reacts with metals which are above hydrogen in the activity series to form metallic sulfate and hydrogen at ordinary temperature. So how do dilute sulfuric acid reacts? Dilute sulfuric acid reacts with metals above hydrogen in the activity series, because whatever metals are there below hydrogen in the reactivity series will not displace hydrogen from dilute acid. As a result, they do not react with dilute sulfuric acid to form salt and hydrogen gas. So metals above hydrogen in the activity series can react with dilute sulfuric acid to produce metal sulfate plus hydrogen gas. So magnesium, these are some of the examples. Magnesium reacts with sulfuric acid to give magnesium sulfate and hydrogen gas, as we know that metal reacts with acid to give salt plus hydrogen gas, and here acid is sulfuric acid and salt will be sulfate because acid is sulfuric acid. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen gas. Iron plus sulfuric acid gives iron sulfate plus hydrogen gas. Noble metals like gold and platinum do not react with sulfuric acid under any condition. Mind you one thing, noble metals like gold and platinum do not react with sulfuric acid under any condition. Not only with sulfuric acid, noble metals like gold and platinum do not react with air, water, or any acid. That's why they are called noble metals, because they are less reactive, very less. You can say they are least reactive. Then it neutralizes bases. Dilute sulfuric acid neutralizes bases to form salts and water. That means this is neutralization reaction. So what is neutralization reaction? The reaction in which base reacts with acid to give salt and water. Base reacts with acid to give salt and water. Your acid will be sulfuric acid and the salt will be sulfate, because sulfuric acid is combining with the base and the result will be sulfate only. If it is acid is HCl, then chlorides will form. If nitric acid will be there, then nitrates will form. If sulfuric acid is there, then sulfate will form. So copper oxide combines with sulfuric acid to form copper sulfate plus water. Iron oxide plus sulfuric acid gives iron sulfate plus water. Zinc hydroxide plus sulfuric acid gives zinc sulfate plus water. Sodium hydroxide plus sulfuric acid gives sodium sulfate plus water. So instead of learning all these reactions, learn this. Base plus acid gives salt plus water, and this is neutralization reaction, and all the salts here are neutral salts. These are neither acidic salt nor basic salt, because there is no H in the molecule. And there is neither OH in the molecule, so they are neutral salts. And another is, it liberates carbon dioxide from metallic carbonates and bicarbonates. So when dilute, here acid means dilute acid. We are talking about dilute sulfuric acid. So whatever acid is written here, these acids are dilute sulfuric acid. So dilute sulfuric acid reacts with carbonates and bicarbonates to give sulfates, metal sulfates plus water plus carbon dioxide gas. So when carbonate or bicarbonate combines with acid, one of the gas will be carbon dioxide gas. Then sodium carbonate combines with dilute sulfuric acid to give sodium salt plus water plus carbon dioxide. Copper carbonate gives copper sulfate plus water plus carbon dioxide. Sodium hydrogen carbonate gives sodium sulfate plus hydrogen water plus carbon dioxide. Potassium hydrogen carbonate gives potassium sulfate plus water plus carbon dioxide. So this is the reaction that takes place with metal carbonate or bicarbonate with dilute sulfuric acid. And what is the result? All the metal sulfates and water and carbon dioxide will be released. And then when dilute sulfuric acid combines with metal sulfide, it gives metal sulfates plus hydrogen sulfide. So whenever sulfide combines with acid, it gives hydrogen sulfide as one of the gas. Then sodium sulfide combines with sulfuric acid to give sodium sulfate plus hydrogen sulfide. Iron sulfide reacts with sulfuric acid to give iron sulfate plus hydrogen sulfide. Zinc sulfide reacts with acid to give zinc sulfate plus hydrogen sulfide. Similarly, it evolves sulfur dioxide from sulfides and hydrogen sulfide. So whenever there is carbonates, carbon dioxide will come. Whenever there is sulfides or hydrogen sulfides, then sulfur dioxide will be coming out. So sodium sulfate plus sulfuric acid gives sodium sulfate plus water plus sulfur dioxide. Sodium hydrogen sulfite plus acid gives sodium sulfate plus water plus sulfur dioxide. So sulfur dioxide is poisonous. and is therefore responsible for polluting environment. So sulfur dioxide is poisonous, and it is responsible for polluting environment. It adversely affects the human health and vegetation. So sulfur dioxide is really dangerous for our environment because it can affect human health as well as vegetations. All the above types of reactions are considered as typical properties. So all the whatever reactions you can see here, these are the types of reactions and are considered as typical properties of dilute acid. So these are the typical properties of dilute acids. Now let's see properties of concentrated sulfuric acid. So we discussed about properties of dilute sulfuric acid. Then now let's see what are the properties of concentrated sulfuric acid. So concentrated sulfuric acid is non-volatile in nature. It has a high boiling point of 338 degrees Celsius. That means it is non-volatile. So it is considered to be non-volatile because its boiling point is 338 degrees Celsius, which cannot be easily achieved. It is therefore used for preparing volatile acids like hydrochloric acid, nitric acid, and acetic acid. So that's why while preparing all these acids like hydrochloric acid, nitric acid, acetic acid, this sulfuric acid is used because it is non-volatile, and from their salts yes, they can be formed from their salts by double decomposition. You can see here salt of volatile acid, and this is concentrated sulfuric acid. So what are the products you will be getting? Acid salt plus volatile acid. So if you are using sodium chloride with the concentrated sulfuric acid, then one of the sodium hydrogen sulfate and hydrochloric acid will be formed. Potassium chloride gives potassium hydrogen sulfate and hydrochloric acid. Sodium nitrate gives sodium hydrogen sulfate plus nitric acid, and potassium nitrate gives potassium hydrogen sulfate plus nitric acid. So this way concentrated sulfuric acid can be used for preparing volatile acid. Then as an oxidizing agent, concentrated sulfuric acid as an oxidizing agent. The oxidizing property of concentrated sulfuric acid is due to the fact that on thermal decomposition it yields nascent oxygen. So it is said that sulfuric acid is the strong oxidizing agent. Sulfuric acid is a strong oxidizing agent. So they may ask you why sulfuric acid acts as a strong oxidizing agent. So the reason is, on thermal decomposition, whenever sulfuric acid decompose, then it can give nascent oxygen. That means oxygen in atomic form, which is responsible for oxidation. Nascent oxygen, or nascent here means atomic oxygen in atomic form. Nascent oxygen oxidizes non-metals, metals, and inorganic compounds. So the capacity of this nascent oxygen is that it can oxidize non-metals, metals, and inorganic compounds. As a result of this nascent oxygen, sulfuric acid is termed as a powerful or strong oxidizing agent. So if someone asks you a question, why sulfuric acid is considered as a strong oxidizing agent, then your answer will be, it is due to the fact that on thermal decomposition, sulfuric acid yields nascent oxygen, which can oxidize non-metal, metals, and inorganic compounds. So you can see here carbon, when combines with sulfuric acid, it can give carbon dioxide plus water plus sulfur dioxide. And when sulfur reacts with sulfuric acid, you will get sulfur dioxide and water. So when nitric acid was combining with carbon, you could see carbon dioxide was coming out, and when sulfur was combining with nitric acid, you were seeing that sulfuric acid was forming. But here no confusion is there. With carbon it gives carbon dioxide and sulfur dioxide gas. With sulfur it gives sulfur dioxide gas and water only. So this you need to know. Then how Concentrated sulfuric acid acts as a dehydrating agent. Dehydrating means removing water. Agent that removes water. Okay. Agent, chemical substance that can remove water, is dehydrating agent. So sulfuric acid has a great affinity for water. It readily removes elements of water from other compounds, that is, it acts as a dehydrating agent. It can remove water molecule. It can remove water from compounds. That's why it is termed as dehydrating agent. So if someone asks you why sulfuric acid is termed as a dehydrating agent, because it can remove water from other compounds as it has a great affinity, great attraction towards water. Then concentrated sulfuric acid removes water of crystallization from salts as well. That means hydrated salts. Hydrated salts means salts with water molecules. So hydrated salts, when combined with concentrated sulfuric acid, they lose water molecules. For example, blue color sulfate, copper sulfate, pentahydrate taken in a test tube becomes white anhydrous copper. Anhydrous means from where water is removed. Copper sulfate, when a few drops of concentrated sulfuric acid are added. So this blue copper sulfate pentahydrate, when treated with few drops of sulfuric acid, gives copper sulfate, which has a dotty white color, removed by acid. That means these 5 molecules of water that is present in one molecule of blue vitriol or copper sulfate acid, this water will be removed. So you can see this water is removed because of concentrated sulfuric acid. As a result, concentrated sulfuric acid can be considered as dehydrating agent, and this is the example. Then all carbohydrates such as glucose, sugar and cellulose, paper, cotton, wood, etc. react immediately to give a black spongy mass of carbon which rises up. Steam is given off and the whole mass gets heated due to an exothermic reaction. They are said to get charred. So glucose, when reacts with concentrated sulfuric acid, gives carbon only. That means it completely burns glucose. White color of glucose, or you can say colorless glucose, converts to black color carbon because water will be removed. Water will be removed because sulfuric acid is a strong dehydrating agent. So water will be removed from this compound and you can see carbon only. Black residue will be left. Even cane sugar or sugar reacts with concentrated sulfuric acid to give sugar, charcoal and water molecule. Water will be evaporated. As soon as you put concentrated sulfuric acid in flour, then flour converts to black color. Flour converts to black color. It will be totally dehydrated. Water will be totally removed. If you happen to spill concentrated sulfuric acid in your skin, then your skin will be totally dry. The portion which is affected by concentrated sulfuric acid will be totally dry. That means it is a strong dehydrating agent. It can remove water molecule from any of the compound. So if you remove water molecule from glucose, you will get carbon only, black color carbon. From sugar also, if you remove water molecule, then you will get sugar charcoal. Carbon obtained in this reaction is very pure and is called sugar charcoal. So carbon obtained in this reaction is very pure and is called sugar charcoal. So what is sugar charcoal? Sugar charcoal is the charcoal obtained when cane sugar combines with sulfuric acid, concentrated sulfuric acid. This is concentrated sulfuric acid. Okay, these are crystals of sugar. You are keeping crystals of sugar here, and through this beaker you are pouring concentrated sulfuric acid. As a result, what you can see here, the steam is going out. So steam means water molecule is going off, and you can see black spongy carbon mass, which is also called sugar charcoal. So concentrated sulfuric acid reacts with the skin to give blisters. because of removal of water and chars the skin black, and skin will convert to black. Okay, skin will convert to black. So this is the end of this chapter, that is sulfuric acid. So this much for today. Thank you.